So welcome to today's lesson on temperature. So quite a few learning objectives to go through today. The first one is understand the concept of absolute zero and how it relates to degrees Celsius. Describe the Kelvin scale and be able to interconvert between Kelvin and degrees Celsius, and understand that increases in temperature result in an increase of speed of gas molecules, increasing kinetic energy as well. And also understand the relationship between Kelvin temperature and the speed of these gas molecules in terms of the average kinetic energy. So it's basically temperature in Kelvin is a measure of the average kinetic energy of a substance. Describe the relationship between pressure and Kelvin temperature for a gas of a sealed container, so a fixed volume, and then use the equation P1 over T1 equals P2 over T2 at constant volume. So absolute zero. So basically absolute zero is the temperature where all motion stops, and it's minus 273.15 degrees Celsius. And we haven't quite got there. We've only got to minus 273.149999999999900 degrees Celsius, but we're nearly there. So it's only a really theoretical concept at the moment. So you can interconvert between the Kelvin temperature scale and degrees Celsius, the Celsius temperature scale, and what you do is that 0 Kelvin is absolute zero, so minus 273 degrees Celsius. So then a change in a Kelvin is the same as a change in 1 degree Celsius. Therefore, for example, 0 degrees Celsius is 273 Kelvin, whereas boiling water at 100 degrees Celsius is 373 Kelvin. And the equation is that the Kelvin temperature is equal to degrees Celsius temperature plus 273. It's important you don't say degrees Kelvin, it's just Kelvin. So there's also a relationship between the pressure of a gas and temperature. So as you heat a gas, the pressure inside a container will increase. The reason why is you're adding kinetic energy to the particles. They move more quickly. They exert therefore more force on the inside surface of a container. So pressure is force divided by area, therefore it creates a greater pressure. And you can see that from the images. A cold gas moves slowly, therefore will hit the inside of a surface with less force, therefore the pressure is lower, when compared to a hot gas, which starts to move faster, hits the surfaces of the inside of the container with more force, therefore it's going to increase the pressure. So in terms of molecular kinetic energy, basically it's saying that Kelvin temperature is a relationship between the average speed and kinetic energy. So the higher the Kelvin temperature, the faster the particles in that particular substance are moving. And they also have higher kinetic energy because kinetic energy is half mv squared. So there, the average kinetic energy of molecules is proportional to the Kelvin temperature. The higher the Kelvin temperature, the higher the average kinetic energy. We also relate that to the pressure law. So the pressure law essentially states that the pressure of a fixed mass of gas in a constant volume, so it's going to be in a constant volume, a constant container of a constant volume, will be proportional to the Kelvin temperature. So if you triple the Kelvin temperature, then the pressure of that container will also triple. So this is actually mathematically shown in the following equation. P1 divided by T1 equals P2 divided by T2, where P1 is the initial pressure, P2 is the final pressure, and the initial Kelvin temperature is T1, and the final Kelvin temperature is T2. So this is all in the same system. So you basically got a set container with a gas inside it of a fixed pressure. You heat it, and then it becomes P2 pressure, second pressure, and a second temperature due to that pressure change. So how do we do this experimentally? Well, you get a round bottom flask, you fill it with dry air, and then you slowly warm it up. So you connect the round bottom flask to a manometer, which measures pressure, and as you slowly increase the temperature, the pressure will change, and you can therefore do a plot of pressure against Kelvin temperature. And this is what you get. You basically get a straight line. There's a proportional relationship between the pressure of a system at fixed volume and the temperature of that particular system. So that also means that P divided by V, the gradient, is going to be a constant. And notice also it goes through the origin, because if there's no pressure, there is no temperature. So how is this useful? Well, it's a way to get to absolute zero, because the straight line crosses the temperature axis at absolute zero, as you can see from the graph, if you do a volume versus temperature plot. And that is an important experiment which was used to experimentally determine the value for absolute zero.